Welcome to this class. In this session, we are going to use limit definition to compute derivatives of these 6 functions. So the first function is f of x, 3x minus 7. B is x squared plus 3x. C is x cubed. D is 1 minus x power minus 1. E, x minus root x. F, x raised power minus a half. So solution. Part A, function is f of x equals to 3x minus 7. Now we know that f prime of x is given by limit as h approaches 0 of f of x plus h minus f of x divided by h. This definition of derivative. Now f of x is 3x minus 7. This is already given the problem, which implies f of x plus h means where there's x here, you put x plus h. So which will be 3x plus 3h minus 7. So then f prime of x will be limit as h approaches 0. This part is 3x plus 3h minus 7 minus, so 3x minus minus is plus 7 and then over h. So I've simply replaced this and this into the formula. So next we'll have f prime of x equals to limit as h approaches 0. You see 3x and minus 3x minus 7 plus 7 cancels out. So we'll have 3h over h, which is nothing but limit as h approaches 0 of 3. And limit of a constant is a constant. So therefore, the answer for that part is 3. Part B, the function is given by f of x equals to x squared plus 3x. Now, we know that f prime of x is limit as h approaches 0, f of x plus h minus f of x divided by h. This is definition of a derivative. So f of x is x squared plus 3x. So this is given in the question. Then it implies that f of x plus h will be x plus h squared plus 3 into x plus h. When you simplify, you get x squared plus h squared plus 2xh plus 3x plus 3h. So then replace back f prime of x will be limit as h approaches 0 of now x squared plus h squared plus 2xh plus 3x plus 3h. So this is a part f of x plus h minus f of x. So x squared minus 3x divided by h. By that substitution, you see some terms will cancel out. X squared minus x squared minus 3x plus 3x. So this will have f prime of x equals to limit as h approaches 0 of h squared plus 2xh plus 3h divided by h. And since every term in the numerator has a h, then we factorize it. So f prime of x will be limit as h approaches 0, h into h plus 2x plus 3 divided by h. Now with that factorization, this h and h cancels out, so we'll have limit as h approaches 0 of h plus 2x plus 3, and therefore by direct substitution, we'll have 0 plus 2x plus 3, which is just 2x plus 3. And then question 3 or C, we have f of x is given by x power 3. Now, we know that the derivative is given by limit as h approaches 0, f of x plus h minus f of x divided by h. This according to the definition of a derivative. Now, f of x is x cubed, already given. F of x plus h will be x plus h power 3, which will be x cubed plus 3x squared h plus 3x h squared plus h power 3. I'm just using binomial expansion to this term here. So derivative of the function will be limit as h approaches 0. Now this is our f of x plus h. So x cubed plus 3x squared h plus 3x h squared plus h cubed minus x power 3 over h. So this and this cancels out. So we'll have f prime of x equals to limit as h approaches 0 of 3x squared h plus 3x h squared plus h power 3 over h. And since each term in the numerator has a h, then we factorize the limit as h approaches 0, h into 3x squared plus 3xh plus h squared over h. We should see that this factorization allows us to cross h and h, so that we'll have f prime of x is limit as h approaches 0, 3x squared plus 3xh plus h squared. Now direct substitution will help you to get the answer. So 3x squared plus 3x times 0 plus 0 squared. So i.e. f prime of x is 3x squared, because this will be 0, this will also be 0. And then next one, D, we have f of x equals to 1 minus x power negative 1. So this can as well be written as 1 minus 1 over x. So f prime of x is limit as h approaches 0, f of x plus h minus f of x divided by h. So let me just put this one under 1 LCM. So I have x minus 1. So f of x will be x minus 1 over x. So this is already given. So that's what you have. So it tells us that now the derivative will be limit as h approaches 0 of x plus h minus 1 over x plus h minus x and then over h. So let's call this one numerator and this one denominator. So let's simplify the numerator. X plus h minus 1 over x plus h minus x minus 1 over x. Put all of them under one LCM. So we'll have x into x plus h minus 1 minus x minus 1 times x plus h. So that will be x squared plus hx minus x minus x squared plus xh minus x minus h, and then divided by x into x plus h. We don't have to open the denominator in this expression. So this will be x squared plus hx minus x squared minus xh plus x plus h, and then divided by x into x plus h. That's by definition. So x squared minus x squared, xh minus xh, x so numerator will just be h over x into x plus h. So therefore, numerator over denominator will be h over x into x plus h divided by h, which will give us h over x into x plus h times the reciprocal. And then we get 1 over x into x plus h. So therefore, the derivative of the function will be limit as h approaches 0 of now this expression. Direct substitution will work. So put 1 over x into x plus 0. This will be 1 over x squared. So, or you can say f prime of x is given by x raised to minus 2. Second last problem. E is f of x is given by x minus root x. So by definition, f prime of x is limit as h approaches 0, f of x plus h minus f of x divided by h. This by definition. And then f of x is x minus root x. This already given in the equation. And f of x plus h will be x plus h minus square root of x plus h. So this means f prime of x will be limit as h approaches 0 of x plus h minus square root of x plus h minus x, and then minus x, and then this minus will be plus. So let me just do it directly. Minus x plus root x divided by h. At least by doing this, x and minus x cancels out. So we have limit as h approaches 0 of h minus square root of x plus h minus root x, and then over h. Over h. Now this is a good expression. So if we have a minus b so this h, remember the same thing can be written as limit as h approaches 0 of h over h minus square root plus h minus square root of h of x divided by h. Actually, I can do this. So if I put a negative here, then I need to put I just negative here. So this is the same as properties of limits. So I say limit as h approaches 0 of h over h minus limit as h approaches 0 of this part now, square root of x plus h minus square root of x and then over h. So this is one. For this one, I rationalize the numerator. So I have x plus h minus root x. So conjugate of this will be square root of x plus h, now plus root x, and then h into square root of x plus h plus square root of x. I'm just using conjugation at this point here. So here will be 1 minus limit as h approaches 0. And these are difference of two squares, so I'll have x plus h minus x over h into root x plus h plus root x. Remember here, taking this one as a, this one as b, so squaring this x plus h, squaring this x. Then this and this cancels out. So I'll have f prime of x equals to 1 minus limit as h approaches 0 of h over h into square root of x plus h plus square root of x. Now by doing that, you can now cancel h and h, so that f prime of x is 1 minus limit as h approaches 0 of 1 over root x plus h plus root x. And direct substitution will work at this point after that factorization. After that simplification, so this means the 1 minus 1 over x plus 0 plus root x. So which means f prime of x equals to 1 minus 1 over, so this will be root 2 root x plus root x, which should be 1 minus 1 over 2 root x. So this will be the solution. So therefore, the derivative of that function is 1 minus 1 over 2 root x. Now lastly, f of x is given by x raised to minus a half, which is the same as saying 1 over x power a half, or 1 over square root of x. So f prime of x is limit as h approaches 0 definition. So f of x is 1 over root x. This is all given in the question. And then f of x plus h would be 1 over square root of x plus h. So which tells us that f prime of x is limit as h approaches 0 of now 1 over root x plus h minus 1 over root x divided by h. Now, let's call this numerator, denominator. So numerator, we have 1 over root x plus h minus 1 over root x. So LCM is root x times root x plus h. So this into LCM, root x times this into LCM, x plus h. So we have f prime of x equals to limit as h approaches 0 of now root x minus root x plus h divided by root x and then root x plus h dividing by h, and just write that h at this point here. Now next we rationalize the numerator. So we'll have f prime of x is limit as h approaches 0 root x minus root x plus h root x plus now root x plus h over h root x and then root x plus h into root x plus root x plus h. Remember, I'm rationalizing the numerator. Now, these are difference of two squares. So I'll have limit as h approaches 0 of now x minus x plus h. I'm putting back so that I don't interfere with signs. Don't bother opening this. There's no need for opening the denominator. So numerator, you open so that now you do away with x. So we'll have x minus x, minus minus, we'll have minus h into root x plus h, root x plus h. Now you see, by opening the numerator, opening the bracket in the numerator, x and x minus x cancels out. So we'll have f prime of x is limit as h approaches 0 minus h into root x plus h, root x plus h. And now the h in the numerator, and this h cancels out. So f prime of x will be limit as h approaches 0, -1, square root of x plus h, and then root x plus h. Because of this simplification, direct substitution will now work. So we'll have -1 root of x plus 0, root x plus root of x plus 0. So simplifying, we get f prime of x will be -1. So root x times root x, and then root x plus root x. Now root x times root x, the same as x power half times x power half. Loss of indices will have x power half plus a half. Half plus a half is x. So half plus a half is 1, so just be x. So therefore we'll have, and this root x plus root x is 2 root x. So f prime of x will be -2x and then root x. So this will be the final solution. Thank you.